Hello, AP Physics 1, it's Mr. Ng with number 7 out of your Giancoli set on momentum. So this is a pretty good question. It's all about the conservation of momentum. Meaning, as we go through this problem, we should try to calculate an initial momentum and make sure that it equals the final momentum. So here, let's just set it up as P initial versus a P final, right? Initial momentum versus a final momentum. And then let's also look for M and V because that's our momentum equation. So let's go through this. A 12,600 kilogram railroad car travels alone. So this is obviously my M. And that's not going to change, I don't think. Let's see. Oh, it will change. So kilograms. Travels alone on a level track, and it has a velocity of 18 meters a second. 18 meters a second. This is good because that means we can find our initial momentum. And then at the end of it, the mass changes. The mass gets heavier. So they drop this 5,000 kilogram load on it. So the new mass becomes 12,600 kilograms plus an additional 5,350 kilograms. Okay, so we have a pretty good setup. This is what we want to know finally. And I think the first thing we got to do is we got to find this initial momentum. So let's figure that out. If we multiply, P0 is equal to 12,600 kilograms times 18 meters a second. If you just kind of punch that in and multiply it, you get 22,6800 kilogram meters per second. Good. So this number, 22,6800 kilograms meters per second, also goes over here because momentum is conserved. Why? Because it's on a level, frictionless track, so there's no outside impulse. So I could write this all over here. 22,6800 kilograms meters per second. So now finding V becomes pretty easy because I know that P final is equal to mass times velocity final. So that means the velocity final is equal to the final momentum divided by our new mass. So let's just plug it in. 22,6800 kilograms meters a second divided by our new mass. So we gotta sum this up. This becomes 17,950 kilograms. 17,950 kilograms. So our new velocity becomes around 12.6 meters a second. Good. So pretty straightforward question, and it's all about the conservation of momentum. The one thing I did was I set up a situation where P0 or P initial is going to equal to P final. I made a situation where I found the initial momentum. That was kind of the key of it. And then I used the initial momentum and I transferred over. I substituted it for the final momentum, and then I solved for V. Thank you very much for watching.